first of all, my office, my group is a cross-cutting group that cuts through all divisions of the City of Austin Transportation Department, but then also through other groups inside the city as well. So in a lot of ways, if you think about what I'm doing, we've got to keep the lights on. We've got to keep our current day of transportation management and operations going, but at the same time, we need to be thinking about the future. And the more that the future starts happening now is really what's been the impetus for me to move from the private sector to the public sector after 25 years of being very, very comfortable in the private sector. So right now I get paid less, I work harder, but I'm happier about what I'm doing. So that's an interesting personal note. So what are we doing at the city? I should mention that in addition to being the director of the Smart Mobility Program Office, I'm also in charge of the Parking Enterprise Division at the city. And so the Parking Enterprise Division is made up of, it handles all of the parking enforcement and management in the city, all the ground transportation operations, so any taxi, limo service up till the state took our power away. We were also permitting TNCs for additional background checks for safety. And then all the curbside, so from the building line all the way out to the curb, and all the parking management on that curbside is also part of the Parking Enterprise Division. You might ask, well, why is the guy that's in charge of smart mobility, right, working in parking? Well, that's because parking in the curbside is ground zero for all of the disruption, right? The road and the lanes is part of it as well, but at the end of the day, where it all happens, where all of the really challenging, chaotic churn of vehicles and modes and people and spaces is all related to what we're doing in those transitions from one mode to another, whether that's getting out of a car and starting to walk, or if you've been paying attention to the news, getting out of a car and getting on an e-scooter. So all of that involves the curbside, and that's where all this kind of transition is going to be taking place from an autonomous perspective. So in the Smart Mobility Program Office, we're basically going to do a series. We're steeped in systems engineering. We're going to do good old-fashioned DOT planning, but at a more advanced level. It's going to be agile, and it's going to use TRB, scenario-based type planning approaches. Oh, yeah. This will get me out from behind there. So, man, the future looks so bright, you just got to wear shades, right? I mean, that's what you hear. Who here has heard about just how utopian this autonomous future is going to be, and then it's going to be here like tomorrow? Raise your hands. Right? You've heard it. Now, keep your hands up if you believe it. Good, good. So, unfortunately, those pundits that like to think that this is going to happen tomorrow, it's not going to happen tomorrow in the United States because of the exact reason that I'm dealing with all these dockless e-scooters right now, right? And it's the regulatory framework that's in the United States. Yes, it can happen in Shenzhen, China, where there is no regulatory framework, there's no protection of ADA and safety and life. You can probably get through a lot of, it's a much more open regulatory field, I'll call it that. So in the United States, we have to worry about certain things, certain laws that we put in place to protect everyone, to make sure everything's equal and equity. And those are the same things that are going to challenge, they're going to add friction to the adoption of a lot of this technology. So while I do believe that we can get here, it ain't going to happen in 5 years. It's not going to happen by 2025. In fact, if you pay attention to this particular area of the marketplace, you're starting to probably get some good scientific media and reports that are saying, hey, we've run the numbers with the simulations that we've done and actually adding autonomous vehicles to the road network in a mixed mode where there's both autonomous vehicles driving and human vehicles driven vehicles on the road. There's going to be more VMT, right? So I'm going to write that down. Right? That's important to everybody here. There's going to be more VMT. The transition is where all that craziness happens. So why are we doing it, and why do we need to keep doing it? Why can we not stop working on AV? Well, the reason is because 40,000 deaths a year. And as y'all have probably paid attention, the number went down Now it's starting to go back up again. It only went down for a little bit with the no texting and driving and some other things, but unfortunately, whatever we do to try to make things safe after the accident are going to be diminishing returns. We need to stop the accidents from happening altogether. The only way we can do that is with connected and autonomous vehicles. So everybody's probably seen a slide like this before. This talks about the levels of autonomy. We're here, right? You can enjoy a level 2 level of autonomy today. If you have a new car, you have what's on there is called ADAS, or ADAS, which stands for Automated Driving Assistance Systems. So that's 2 or more automated systems working together. That's where you might have lane keeping and automated cruise control, so you're going down I-10 and not having to worry too much about where your foot and your hand placement is. Level 3 is where we're currently doing a lot of testing. Level 3 is available from some manufacturers, and this is where you're seeing a lot of the testing done, where there's either a safety driver in the car, there's still a steering wheel and brakes and all that sort of stuff. But at the end of the day, the driver, that in level 3, the driver is the operator, whatever you want to call them. Again, we have to come up with whole new terminology for all this too. But the operator or person that's sitting in the once was driver's seat is not having to pay attention as much, but does need to take over control at a moment's notice. Whenever the car's like, I can't deal with this, you have to take control. Level 4 is where we are now, where you've seen current news articles, other things related to autonomous vehicles. That's where there's still a human in the vehicle, but that human isn't necessarily operating anything in the vehicle unless there is a major failure. And in that particular case of the most recent news, that ended up being part of the problem, right? So that's where the current state of the practice is related to autonomy. I am going to get into some really good and saucy things. So everybody's seen the things that have happened. You know, the Tesla crash, for instance. So NHTSA and NTSB are just finishing up their investigation on that. You can go out and Google right now and you'll see there's recent news articles related to some of the findings related to that investigation. So, you know, that one's one that happened in California a little while ago, right? So understand it takes a long time for the government to get in and unpack that incident and the crash and then look at all the systems that were, you know, there's little black boxes, by the way, in all these AVs that monitor every little system that's a part of the AV system. So that, you know, if you're GM, I mean, you're really a builder of parts, right? You collect tier 1 pieces and you really just assemble it. So at the end of the day, whatever you're assembling, right, if some of that broke, you don't want to take the full liability of that. You want to put that on whoever you bought it from, right? And so there's these telemetry systems that they're building and designing this like the black box in an airplane so that if there's a crash, they can hit rewind and decide what happened and who was at fault, and more importantly, what subsystem in the vehicle was at fault. But, you know, it's not really, it's partially the vehicle, it's partially the technology, but it's also, in my opinion, the environment, right? And then when you say environment, that involves government, that involves private sector, as well as the community. And in all of these cases, what you'll notice is that the environment wasn't perfect, right? Well, there never is going to be a perfect environment. And so it begs the question, to what level of on-street live AV testing do we need to do? Can we really make AV work if we put all of the testing and put it in a lab and say, oh, it can't go out on the street until it's perfect? Well, the people who say that don't really understand AI and AV very well. So, yeah. So you think AV can handle a, you know, so AV systems, by the way, so there's 2 parts to it, right? There's the map that's already loaded onto the car, right? And that's this high definition map down to, you know, 1/8 of an inch as far as where the curb is and all that sort of stuff. You know, lane lines, all the markings, signs as well for whatever they can LiDAR before they put the vehicle out there, in addition to the LiDAR that's already on the unit. on the car. And so it's a combination of all the sensors that's collecting all the information and the map, right? And what the AI is mostly doing is looking for differences between the Bible they were given of what should be out there and what they're seeing, right? And whenever they see something that they can't compute, that's when they have problems. So if it's a stop sign, well, they know what those look like, but if a flagger's flipping it around, well, am I stopping or am I slowing? I don't know. Same thing in construction zones. Signs that are tilted, things that are non-standard in what you would consider to be a standard arterial view. These are the things that they have trained the AIs to do. They haven't figured out how to train them to do this yet because, quite honestly, it's Baskin-Robbins of flavors of issues they have to deal with. Hence the reason why AVs need to continue to do on-street testing. Who has ever used the Google Recaptcha system? Show of hands of people that actually know what you're doing. All right, so if you've ever been on there and you heard what I just said, all right, when an AV has a problem and it doesn't know how to read what it's looking at in the picture and the LiDAR or whatever, it's got to ask a human for help. Go back 7 years when Facebook launched their little Facebook Messenger bot, that you could talk to and it'd talk back to you, and it took about 20 seconds before somebody figured out that you could talk lewdly to it and it'd talk lewdly back to you. And that was fun for a little while until Zuckerberg had to pull the plug out of it, right? And then it was a couple of days and they suspended it, but they brought it back because they had to save face, to be honest. Well, what they did is they hired about 3,500 college kids to basically proofread every one of the things that the bot did because they hadn't figured out yet how to get the bot to think more like a human, and that some of these things, some of these rules, unsaid rules, are things that are very important as it relates to autonomous vehicles and, more importantly, artificial intelligence. So, in every one of these that you do, you're helping Google and you're helping AV and AI across the world. Being that they've done the most miles and they have the most trained AI, is what they would say. I'm not going to argue that. I don't really have data to say whether they are or aren't. But if you're one of the largest data purveyors and traffickers in the world, and you have a lot of really smart people working for you, and you need to train your AI, right? And you're putting your AVs out, and they're coming back with all of these images. Hey, I don't know how to read this. Now, you're going to hire one engineer to go through and find all those and tell the AI what they should be looking for? Are you going to hire 100? Or are you going to find some way through another type of system, right, that does something else for the public good, right, making sure that you're not a bot trying to log into your Facebook account or whatever, right? And through the world, we found a way to help train AI. Because every one of these that you look at comes from a camera or a sensor off of one of Google's autonomous vehicles, or one of their other projects that they're doing where they're trying to advance and iterate and innovate on their AI. So it's not all their vehicles, but a good portion of them are. And they're all things that they can't figure out. Like, they can read that and that. They understand that that's a stop sign as far as the shape of it, but it doesn't look like what it looks like in the computer, Flags and banners, so you think about like races and stuff like that, or fall festivals, and they put the banner things on the poles, right? They have letters on them. They're blowing in the wind. If I'm a human, I can reason, okay, I'm going to glance at it a couple of times, but I don't need to pay attention to that, right? If I'm a computer, I'm taking it all in, right? And then I'm having to compute whether or not I keep it in the basket or out of the basket. And so if I'm sitting there watching this thing that may have letters, this is a flag, it's a bad example, but think of there's a race day and they got a banner across the street or something like that. In the one in this one, right? Well, their map says that that's a four-way stop. Or maybe it's just a through street. But there should be a sign, there should be a stop sign according to their map, right? But since that sign is because there's a stop bar, right, and depending on where this is, local regulation may say, well, you're not required to have a full-on stop sign depending on the level of traffic, right? You do your engineering study to understand why. But in their system, they think there should be a sign there, so they want to know why. So I say all this because it's up to all of us to continue to train the AI. You're doing it, you didn't know it, now you know it, so please keep doing it. It's the only way that we're going to reduce the 40,000 deaths a year at the end of the day. This is where we are today. You know, and I mean, believe it or not, and this is kind of where it gets into the problem, right? This is, everybody talks about the utopia, but it's the transition that's probably the hardest thing to bear with all this. And quite honestly, it's going to be a lot longer than anybody thinks. And why is it going to be long? Well, because of all the stuff that I've just showed you. You know, little things like that bent in that sign are going to cause problems. Maybe not during the day, but reflectivity at night. Okay? These kind of things on corners where, you know, an AV can't really tell, is this all related to me? I can't really tell that these signs over here are for, you know, a whole different movement off of this intersection. These are a lot of their challenges, right? This transition and the data associated with this, because, you know, they're just trying to sense it from what's out there. They haven't figured out that they can ask us for help, you know. They figured out how to get us to help without us knowing, you know, earlier. But now they need to ask us for help. And that's why I think that, you know, this road to learning involves all of us, right? From this point forward, it really needs to involve everybody. Now, I'm a lake rat. I live out by Lake Travis. So I was driving down to Carlos and Charlie's, or not, I forget what it's called now, but you know, they're everywhere around the lake. They have one of these signs. Well, there's no stop sign down at the at the ramp. Is an AV going to know that he can't drive into the lake? Probably not been coded yet. We got disruption for days, y'all. Look at this. So, I mean, here's a very good example of just, you know, tagging and bad stuff, but an AV has to try to read that sign. So how does it read that sign with all that junk on it? It's pretty hard. So that's where smart infrastructure, you know, some of the things that you're seeing, some of the sign materials manufacturers work on, you know, they're doing things where they're unique innovations that are starting to happen where you can actually use materials and colors, and still for a human, they see a normal stop sign. But for a car, they see a QR code or something like that. And then from that QR code, which as you know can host a lot of information, that quickly will give the AV the ability to know exactly what that sign is, regardless of the condition of the face of the sign. Or, in the case of that one, regardless of the fact that one of the screws fell out and it's upside down. Believe it or not, AVs don't know what to do with that. They have figured out that, like, so where you have highway signs with the state emblem behind it, they use that. They figured out how to trace that shape and say, okay, I'm in Texas. But if that sign turns upside down, then all of a sudden it's got a really big problem, right? Because its sensors are saying that it's in a state that doesn't exist, and its map says it's in Texas. So that's a problem as well. And do remember that AVs, when they have major issues, like major failures, the failover systems are to be able to bring that car to a safe stop, and preferably under the shoulder. So these systems do have the ability to, if they completely fail, still bring the vehicle over in a safe manner over the side of the road. So I said earlier about the signs, right? And so some university grads at WashU and a few other universities got together and said, hey, you know, we've been listening to what the sign material people have been saying, but I wonder if we could hack an AV by simply putting stuff on top of an existing sign. So what if I were to tell you that this particular right turn arrow with the pixelization of these white pieces of tape, I think they actually used one of those whiteout pen thingies originally. An AV thinks that that is a right lane add or drop sign. not so bad, right? This one over here with the 2 pieces of white tape, duct tape, and the 2 pieces of black tape, AV thinks that's a 45-mile-an-hour speed sign. That's a big problem. So there, you can, right now, you can hack an AV by somebody just arbitrarily going out there and putting some tape on it. So therein lies part of why every one of you are part of the solution. Because the asset management community in transportation collects all the data, right? All of this data is hugely important to these guys. All we have to do is find, right now, it's, as Joe mentioned, it's here, right? And Joe mentioned our conversations, and Joe was saying, yeah, we've always thought like we're sort of the afterthought. After all the AV stuff happens, we'll see some of the data that we need to collect and that sort of stuff. And I challenge you that the data you're collecting now is actually the gap that is needed to take the next step in autonomy. Without us sharing our data of our infrastructure, AVs only have half or a third of the picture. They got the map, they got the sensors. The last piece they need is the data that we have. If they had data to say that at that location, we know for sure that's a stop sign, somebody's been out there and hacked that stop sign, treat it as a stop sign, we can verify, validate, comes from government data, right? They will prioritize that. They want to prioritize the map. They want to prioritize government data. They use the sensors to figure out anything in between, and then use the algorithms to decide, is that truth or not, right? Based off of a three-part scientific answer, right? If I get 2 of the 3, it should tell me that it's this. So in a lot of ways, the things that we document and where they are, regardless of whether we make some of the infrastructure smart or not, the amount of data that we collect today is very, very valuable to these companies. The problem is they can't really figure out how to use it. And I'll get into that a little bit later. So signs, lane markings, same kind of thing. These are just some non-standard things that AVs don't quite understand how to compute. You can put them into the map, which is great. But at the end of the day, when they go out and look at what was in the map versus what's in real, right? In the map, in the map, the bike lane wasn't superimposed on top of the edge of travel lane. There wasn't this arbitrary temporary construction sign. So there's different things. This particular one, the engineering file had the bike lanes on the other side of the road when they constructed it, so there was no as-built. I come from construction, so I love as-built, right? And you're going to find out that as-built are going to continue to be the bane of our existence. Potholes. Guess what? AVs don't like potholes. Pothole to an AV system, to the telemetry systems and the gyro in it, it thinks that you just hit somebody. So big potholes are big problems. AVs right now, I'm talking to different AV companies that want to do some testing in Austin, in closed street environment, right, where we can control the people that are on the sidewalks and all that sort of stuff right now. But talking with them, we're just ideating about, where in Austin we can do this. Some of their biggest concerns are, bad road conditions, propensity for jaywalkers, so probably not UT, things like that. These are where you guys understand where we're going to see these demonstrations, these pilots, these proving grounds on autonomy happen. You're likely going to see a lot of long-haul stuff. I know we have a lot of DOT folks here. So from a DOT perspective, my past job in the private sector was mostly working for the DOT as a consultant. You've probably heard it. It's in trucking. So you're going to hit the industries that are having the biggest issues now. So trucking and transit. Long-haul trucking, because same thing with both marketplaces. Average age of the driver is about 50 or older, no one new coming in, and at the end of the day, they can't handle the service hours with the drivers that they have. The demand's higher than the current regulations, so there needs to be a give somewhere. They think that that's likely going to happen in autonomy. So long-haul trucking, inner-city trucking, and the like, I think, is what you'll see in that. So in a city, we're getting everything a lot more compact and connected. That's sort of the trend at the city, right? In any city you go to, it's about trying to create these walkable, livable places in the city so that we can get around a little bit easier. The idea is that if we can remove the need as well as the dependency on single occupant vehicles and parking, then it'll help us with this big transition that happens, right? And it's not like on 2040 I'm just going to demolish and implode all the parking garages in town and say, okay, everybody's going to have to do an AV today. No, it's going to happen over a very long period of time. And as part of that, you'll see things happen at the municipal level where municipal government is beginning to plan for a lot of that from a land use standpoint or from other overarching big block movement standpoints, I'll call it. But in all of this, these are all new things, right? We're inventing new things every day for our transportation landscape, you know. And so if you ask an AV, stop, give us a chance to learn all what you already did, you know, but we can't, right? And so we got to start funneling them some information, you know, so they can catch up to what we know, and then ultimately that'll allow a discussion to happen where we can talk more meaningfully together. Because right now there's a big gap between how we collect our data, right, and how they look at data. You know, we're infrastructure purveyors at the end of the day. You know, we talk to people, usually our communities, to understand need at the beginning of projects, but then a lot of times we're not connected to them in a level of pervasiveness and behavior like there's a lot of the apps on our phones. Well, I mean, who uses an app on a phone today to get around travel-wise? A good many of you probably, right? Well, I was in DC right after the omnibus. What if I told you that right now USDOT is trying to figure out what does it mean to be a modern transportation user experience officer? A new term, right? All right, technology in these tech companies, the UXO, is usually one of the top 3 paid people in any company. Why? Well, they're number one, they're usually ex-FBI profilers. Number 2, their whole job is to make sure that you get addicted to CryptoKitty or whatever new game comes out. Understanding that mobile phones and mobile internet and the pervasiveness of personal mobility through apps is going to be the wave of the future, you got to start asking yourselves, what does the transportation user experience officer look like? Because at the end of the day, those are our customers. Those are the people that ride on our roads, and ultimately it's our responsibility to make sure they're safe. The only way we can really do that in the future is to better understand the behaviors of everyone out there, and then some way find a way to collect that information anonymously and be able to use that information for better operations, for better planning, etc. So, you think an AV is confused with all this underground utility locates? I would be. I'm confused. And I work in that area. I was a communications consultant. What's interesting is that you know, they've figured out a way to make sure that the cars are just paying attention to the painted lines. But you know, depending on how you go, a locate company goes out there and locates, somebody gets a little extra happy with spray paint or messes it up and has to make a big white mark, you know, all of a sudden that might look like a dashed, you know, lane divider or something else. Facilities. So as I said earlier, mayor and council put together through a resolution that they wanted to hire somebody, and then they left it up to Rob Spiller, the director of the transportation department, to decide where that person was going to live, and I live in the parking division. A lot of people are like, why? As I said earlier, it's going to be where most of this stuff's going to happen. So if you build parking garages, you know the financial play on that's about 40 years. So if you're building one today and you're not thinking about how you're going to use that in 20 years from now, then you probably should stop planning it at this point and take a breath and think about what mobility is going to look like when you're just getting to the point where you think you're going to be making money on it. Because I'll tell you, you're not, unless you do something like this. Right now, the numbers show that with full autonomy, the wonderful, utopian society model, we could see upwards of 90% reduction in the need for parking, the demand of parking. All right. My parking division represents 2/3 of Austin Transportation Department's revenue that we use for our programs. This is a direct hit to every city and their transportation budget. So I am paying attention to this. I will tell you the numbers that I ran, we could see upwards of 20% in the next 5 years, just from all this other stuff that's going on. These little dockless scooters and then these other last mile solutions, TNCs, it's began already to erode parking revenues. We've already seen it in the city of Austin. And we're going to continue to see that. As more of these other rich modes of last mile transportation start to happen, people aren't going to need to do these short trip parking garage trips. People are going to start figuring out that with all these rich modes inside the city, it's better for me, it's faster for me to not drive all the way into the city center and park, even though convenience-wise, it made sense today. And obviously, dockless bikes is good for like UT students, but I'm not riding one, certainly not in August. So these little scooters are great, right? Because they're electric. We're lazy. We push a button and go. That's awesome. And there are a lot of great things about those scooters. So think about all these different little pieces of mobility that are happening right now, right? And think about how that's going to change your overall facility design. Maybe it's not a parking, maybe it's a parking garage today, but it's mixed use tomorrow. Maybe if you're doing a building, and you're looking at how much parking you're going to have, you might need to have a little bit of parking now, or a significant amount of parking now, but a plan on how you're going to reuse some of that land space later for either drop-off pickup zones, AV charging areas, EV charging areas, things like that. These are some examples of some concepts that could probably happen. Actually, the one over there on the far right is a concept of a garage that did get turned into mixed use in Shanghai. Smart mobility, autonomy, it's all, there's three major pieces in vehicle technology that are happening right now that are all kind of converging. And that's electric vehicle, connected vehicle, and autonomous vehicle technologies. And eventually they're all going to converge into one. We're starting to see that happen here in Austin because we're one of the few cities in the United States that's actually set up to be able to handle EV charging. That's the reason that GM launched their Maven program here in Austin right before South by. So they're bringing just the bolts to town, and it's a transportation as a service, kind of like Car2Go or Zipcar. You can walk up, unlock one of these things, and start driving it. The difference is that their model is built around being able to provide people who want to drive for TNCs the ability to drive if they don't have a vehicle that is worthy of driving for a TNC. This gives them the ability at a very low rate to get into a vehicle, drive as a TNC, and handle all of the finances between those two companies eventually through one user experience, one driver experience. That's a great story because that's taking more people that are low, moderate income that may not have a vehicle to operate in a TNC, and it gives them the ability to do it. People are like, well, why are you focusing on TNCs? Well, right now, you got to be careful about how much we focus in on the taxi industry. In October of 2017, the last taxi ride happened in Waco, Texas. There is currently no more taxi industry in Waco. It's all been disrupted and completely been put out of business by the TNC industry. People are like, well, I kind of like the TNCs better anyway. Well, that's one thing, but I guarantee you most of you in here at least know that in the taxi industry, that's how government makes sure that there's a little bit of equity in place, right? TNCs don't have any requirement to handle ADA. You can look and go online and look at the stories of the number of Uber drivers or other drivers, Lyft, whatever, that have pulled up to pick up a ride and that person been wheelchair bound and they take off. That's one of the reasons why there needs to be some level of regulation, because otherwise, what are we doing to our disabled citizens if they can't get mobile? If they can't stay mobile, then everybody here knows what happens if you lose mobility. So electric vehicles are a part of that. It's important to note that right now it's all slow trickle chargers, or in Austin we have the DC fast charging. And there's one over there on Seaholm, Electric Drive. There's going to be about 20 around town by the end of the summer. The GM entering and choosing Austin for their program actually was sort of the impetus for that, but the underlying infrastructure has been there for a while. This is where you're currently, if you're doing any development and land development or anything, you're probably currently looking at exactly how many of these you're going to need. They're pretty expensive. It requires a whole different level of energy transfer to that place. So if you think about EVs and some of the government regulations around them, you can't charge them with coal-burning energy. That doesn't really move the needle, right? So you have to show that you're using green energy to charge these things. And Austin Energy is one of the few energy utilities in the country who's already gotten that part done. And that's because mayor and council put that into action about almost 10 years ago. Does it affect fleets? Of course it does. There's more electric vehicles outside. That means that all the kind of services, hero programs, road patrols, all of it are needing new things. And when autonomy comes around, that's just a whole nother level of stuff. You think about traffic incident management, what do you do at incident scenes? It's going to get even more interesting as we look at cars that may have crashed but have some type of error in it, and it's still or something like that. Personal mobility today. So as I mentioned earlier, these little scooters have basically taken my attention away for the last 3 weeks. As y'all may know, if you've seen them around town, this is a dockless mobility solution where, unlike Austin B-Cycle and a lot of the dock systems, you see where you have to put the device back where you got it from or in one of its places. The dockless mobility solution basically allows you to pick something up wherever it is, take it wherever you want, and then leave it there. We've deemed this particular issue because they're, where they're leaving it and how they're leaving it is the safety issue. A customer maybe hasn't been trained in understanding exactly what trip hazards are on sidewalks, or that if you lean one of these things up against an ADA handrail on an ADA ramp and it slides down, or even if it just stays there, that you're occluding ADA access, right? Or that if you put one on a short 4-foot sidewalk right in front of a door, and that door happens to be the major fire egress, well, now we've got national fire code problems too. So all those kind of things are things that'll eventually get worked out through just education and outreach, but that's the reason that cities and states need to have the ability to say, wait a second, before you just go out and start deploying this stuff, let's think about how you're making sure that it's safe. And the reason we need to do that is because, as Joe mentioned, I go to China every 2 years. Basically, it's my research trip to better understand what we're about to see, because they're able to do it out there a lot faster than we can here. I can tell you right now that all of these particular modes are in operation in somewhere in Asia. Personal mobility pods, that currently where you drive yourself, this one right here is a Honda. That's the Toyota iRoad, which is launched concept-wise in Tokyo. GM's EnviPod. I think that's an iRoad again. I forget. I think that's Nissan's over there. But basically, these things you walk up with your phone, they unlock and autonomously. Some of them scissor out, so you can step in. You don't even have to bend down. You just kind of step into it, and then pod comes over. So if I've got dockless scooters littering my sidewalks now, what are these things going to do, right? If the dockless scooters are already challenging regulation and framework in our government sector, state or local, right? Then what are these things going to do, right? I mean, the code that I'm currently using to help try to police from a safety perspective these e-scooters was last touched in '92. Yeah, okay, I'm exposing the fact that we haven't touched the ordinance since '92. I'm new to the city, so okay. I guarantee you all of us probably have that. And what it tells me is that if an ordinance hasn't been touched since then, that means that it is not mobile phone ready at all, which means that what vending in the right of way? Well, I mean, if anybody walking down the road doing an Amazon purchase, is that vending in the right of way? I don't know. No, probably not. You know, it's more related to mobility, right, in these devices. So we have to be careful about how we react to all this stuff too. If you overreact, you may create an ordinance that then limits you later. You know, if you underreact, you may create a level of chaos in your town that you'll lose the political will to do anything at all ever again. So, you know, it's a very fine line that you have to walk in this area of emerging mobility. So in China, or this is in Barcelona, I think. Yeah, this is Barcelona. They've got the iRoads running in Barcelona as well on a little pilot project, and all electric. I like the two-wheel in the front and the one-wheel in the back because getting them in and out of tight spaces is really easy, you know, when they can basically do a 0.360 turn. So the designs are really coming along from where they were even just 5 years ago. I'm getting close to the end, so, and I have enough time for questions. Perfect. Alphabet, Google, whatever you want to call them, they have a program called Link. The name of the company that they've created under Alphabet's called Intersection. In New York, this is all part of the US DOT Smart Cities Challenge. If anybody was in that, you saw these. If you were one of the finalists or the big finalists in that, then you know you got a little information about this from Alphabet. So you know these things are interesting because to me they give the social equity component of people that can't have phones, right? Because this gives them the ability to walk up and use a lot of the same kind of services that others that may have phones can do. So in addition to that, people that walk up to it or use it for the free Wi-Fi that they have, it gives us the ability to better understand trip volumes, movement through the city, particular travel behaviors. Again, you know, depending on the solution and who's providing it, you got to be careful about the data and make sure that you're not collecting any PII or personally identifiable information. But I like this picture because it proves another point to me. I mean, this is a smart city deployment in New York. We're working with Google to better understand how they may be able to deploy these here. Honestly, they're built around an advertising model. And in the city of Austin, there's a no advertising with digital signage ordinance. So we have some challenges, like a lot of cities do. But I like this one because of that. Right there. Yeah, really the whole frickin' thing. Right? Because if I'm at AV, I'm reading that and that. I'm trying to read that. I'm reading that. I'm reading that, but going, well, it's sideways, so I don't care that much. But then in that one, I'm like, that's in my database. You know, but I don't have it all. You know, so what's wrong with that sign? A lot of things. It should be on the other side of the frickin' pole. This is what the near future of a curbside is going to look like. Thanks to our friends at MIT. You're going to see where, you know, bus pullouts, you know, and current traditional transit pullouts are going to look a lot different. They're going to be a lot more multimodal. They're going to need to handle TNCs. They're going to need to handle microtransit and autonomous people mover pod things that I just showed you in this picture. It's all getting disrupted. But this is what it could look like. Getting back to that utopia again, right? The ability to have, you know, an uncluttered, open right-of-way area with you know, just-in-time mobility services coming and picking you up where you're not having to use as much in the right-of-way. You know, in a utopian area like this, there's very little friction in the transportation system. And a lot of people ask, well, how do you get there, right? How do we get from the very heavy friction level of mobility we have today to a place that has less friction? I wanted to show you this real quick. This is basically what an AV is seeing. This has been post-processed, so it's not You're not seeing the blockouts for any of the other stuff, but you can just see from this quick little 2-second GIF what it's doing, how many people, how many objects it has to track. And that's just at one intersection, and quite honestly, it's not moving. So, this is the one slide, if you wanted to take a picture, you probably should. Where are we, how do we unlock value in asset management related to how you all can help in the world of autonomy? Real-time asset management. So from all of this, right, you can get an understanding of how real-time asset management in the future is critical to making sure that AVs have the latest and greatest information, right? So that we understand the conditions of our assets in a more timely fashion, and we're able to expose that information to the private sector so they can pick it up and use it how they will. Open data, new frameworks. NACTO is working with US DOT. That's kind of an interesting thing all in of itself. NACTO is working with US DOT on a new open smart mobility framework. So, as I mentioned earlier, this friction, right? A lot of us we met in DC and we were ideating around, okay, well, how do we get this friction out of these different modes? You know, you got mode splits, you got modes that are competing with one another. And so we kind of had an exercise where we put all the modes on top of one another in a layer, in a GIS layer, right? And we tried to find ways to make those layers as translucent as possible as far as all of the details of those modes and why there's the friction. And what we were trying to do, the exercise we were trying to do, is to understand what are the commonalities between those different modes and different pieces of infrastructure, because if you find those commonalities, right, this is sort of a different way of looking at data that we normally don't look at in transportation, but outside in the private sector, they look at data this way much more often than we do. And that's because they haven't spent the last 100 years focused on infrastructure. They've been spending most of their time focused on you and me and our behaviors. And I challenge you, that is something that we as an industry need to do more of. We need to understand and touch our users all the way through the process, not just in the beginning. And then more importantly, as I mentioned on the UXO thing, we need to better understand the behaviors of these people. And so there's a small little group that's working on what we call PST. So when I went and we did all that and we looked at what was there was 3 common things between when you stripped away the mode, you stripped away where the vehicle was, where it was, you know, because it's, you know, on this one curbside that's not the right one or whatever. We went through lots of different scenarios. There's 3 things that were common amongst all of that. And that was people, space, and time. More importantly, where the people are. So what space do those people occupy and when and for how long? So rather than looking at things the way we normally do in infrastructure as far as vehicles, right, time-space diagrams, things that focus on infrastructure, you wonder why we're having so much hard time talking about data sharing with these private companies. It's because we're talking 2 different languages. At the end of the day, at the federal level, we've started to figure out that we're not talking the same language. And that's the reason why a lot of these companies don't want to share data with us, because quite honestly, they don't understand, and at the end of the day, they don't care about that level of granularity related to the infrastructure. They want the metadata associated with the infrastructure, and that is people, space, and time. I say that because we need to move more agilely, right? We need to move towards more scenario-based planning so that we can move quicker with industry. We need to map more. And we need that mapping to be done more in real time so that as changes happen out in the world, that data is getting pushed back into a system that then can basically expose that data for the private sector to pick up. If anybody were to ask me right now what's my biggest mapping need, I need to map my sidewalks. I need to map from the building line to the curbside. And I need to know all the infrastructure associated with that, right? So that I can get to the PST, the people, space, and time. But I also need to know, I need to take all of my ordinances that go back to 1920, and I need to spread those as a layer over that as well, right? And the reason I need that is because the private sector and some very invasive business models have already done that. And they already know the holes in my ordinances and where those ordinances spread out like peanut butter on my infrastructure. They know where to go. You know, did I want to pick up every single one of these things that launched in the middle of our pilot? Yes. Did I have the ability to do so? No. And therein lies part of the problem. We need to get serious. We've been talking about it for years, but we need to get serious about the digital transformation in transportation. And it means that we actually need to spend money, we need to focus monies on big data architecture types of movements inside DOTs. I know that TxDOT, for instance, is moving forward with an open data program that's very interesting. DOT partners, when they partner with cities to do this, I think you're going to get a lot of movement, a lot of momentum, because the connections are already happening at the federal level and at the national level between like USDOT, AASHTO, and NACTO. And then ultimately, you know, if we can get serious about it and figure out our data, it'll give us the ability to pivot with disruption rather than against it. That's what we have to do right now. We're really reacting. I want to get out of that to where we're proactively understanding how we can take advantage of some of the rich solutions that the private sector has to offer. And then where is all that going to happen? As I said before, in my area. So this is my last slide. I wanted to showcase that, you know, Austin has a smart mobility roadmap. This includes 5 major areas of what we consider to be smart mobility. Those are shared mobility, autonomous vehicles, electric, land use, and data and technology. AV to the city automatically includes CV. And I would say that everyone needs to start using that type of vernacular. And the reason is that incidents of late that have happened related to AVs, if those vehicles were connected and communicating with other AVs with the roadside, as well as connected vehicles that are human-driven, then that AV would have more information than it currently has. An autonomous vehicle that is not connected to any other vehicle on the road, I would argue, is less safe than a human-driven vehicle today. We as humans can communicate with one another, right? I can give you eye contact. I can use hand gestures, both good and not so good. But at the end of the day, there's a level of communication that 2 human-driven vehicles can do, right? An AV that's driving on its own that can't communicate with anything else is worse right now. We need to make sure that when we're talking about autonomous vehicles, connectivity is a baked-in understanding, because you can't get to the level of reducing deaths if an AV, and as I said, they're not as trained as we are as drivers right now, is acting as its own. That's like me putting my 13-year-old daughter in a car and telling her to drive. Right? You should expect the outcome you're going to get. And so do know, keep that in mind. I want to make sure that all the DOT people out here, you know, don't think that autonomous, the Connect is not anywhere represented. It's represented in all the autonomous pieces. And so that's my last slide. I got enough time for maybe a couple questions. But I wanted to thank y'all all for your time and attention, and appreciated talking with you.
You mentioned about the connected vehicles. Do you think because of all the focus on AV, somehow the development and the progress that the federal government pushed for on the connected vehicle area kind of like overshadowed, because is the OEMs are focusing more on the AVs, not on the connected vehicles, and NHTSA has already backed down from mandating it. Do you think that is the case?
So I think that just like this dockless bike, and we had a dockless bike system, and then all of a sudden we thought the scooters were a year away, and then they showed up tomorrow. Same thing happened with CV and AV. You know, USDOT for years, we've been really focused on developing connected vehicle, getting the standards, getting the certification, all of the message sets, right? All of it. You know, I used to chair OmniAir, which is the Wi-Fi alliance of connected vehicle. So And it's responsible for everything up the stack, over the air, and down the stack again related to vehicle to anything. And so, the DOT's been focused on making sure that connected vehicle is designed, safety is designed in, right? Because that's the focus with connected vehicle. Unfortunately, as you mentioned, the private sector kind of jumped over us and surprised us. Well, we had our nose in the book on connected vehicle. We looked up off the page and AV was here. That's why you see the big the line item in the omnibus for AV safety. US DOT has figured out that they need to quickly drop back, ideate, and create a level of ideation and eventually regulation that will help cities and states understand how we can better work with AVs in the future.
Thinking of other questions, one question I had is, you were showing all of the distractions that an autonomous vehicle may have a struggle with. What about when you add weather over that? Raining and nightfall and winter, like snow and ice. Is there a path forward that's going to get through all that, and what does it look like?
There is. If you look at where all the AV testing has been done, there's this big L, West Coast, California, Arizona. They're hitting all the sunny states right now on purpose. Weather is a tough one. These sensors are very sensitive that are out, the lenses that cover the sensor, for instance. I mean, you just can't run these things through an automated car wash. So if you think about salt spray and how that affects, just the amount of lumens that comes out of your headlights, imagine what that's doing to a camera array that's trying to pick up this stuff, right? So yeah, there's serious things that we got to figure out, in the northern states, and especially during adverse weather conditions. Rain's pretty good. Rain's something they can deal with, not a problem there. Rain at night, also not that big of a challenge. You got to remember, as I said before, it's that three-legged stool of the high definition map, the sensors, and then on top of that, any data they can get. That's where you can't run at night if you don't have more data. That's really where when you look at these adverse conditions, these adverse environments, that's where they really need our biggest help, because those are the places where they need our data in order to really operate.
Great. Did I see a question up here? Yeah.
So my question is more around the dockless scooters that you've got running around here. As an engineer, I think many of the people in this room, they don't like things just kind of floating around their desks. They have places for everything. I can see how adopting it to an automobile would be a lot easier because you have parking spots. Everyone grows up knowing what a parking spot is. You believe in it at this point. I'm not sure if that's something that had been considered as far as implementing in front of buildings and whatnot. Almost like you have a bike rack.
Yep, yeah, and we are. We're using, so DC is doing a pilot right now with 2 of the dockless bike companies, where they basically went on the sidewalk and they painted a box. And so the idea is to start training the users, the customers, to put them in the box. And so, and they're trying out, one of the particular vendors has a haptic response on their bike, and so it buzzes. And so they're trying to use that haptic response to say that they put it in the right place, and they're also trying to use a reward gamification type of thing to, you get points if you put it in the right place. The next step is really going technology-based. I think it's closer to what you're seeing Lyft do with San Francisco related to TNC drop-off pickup. There's some curb faces that are just way too chaotic, and so they're working hand in hand with the city over there to create geofence drop-off pickup zones. So basically, when they create that geofence, it allows both people to get a new direction and where to go meet. And that takes all of the chaos and all of the impact from a traffic safety perspective out of that particular block face, and maybe puts it on a perpendicular one that is not as heavily traveled or something like that, or is easier and safer. And so related to the bikes and the scooters, I think a geofenced type of system eventually is the one that will probably stick around, so that we don't have to run around and paint stuff all over the place.
Oh, yeah. Time for another one here? Sure.
I just had a question about the mapping. like you're saying high definition mapping, and do you go back to CAD drawings, like geometry, and then bring that into GIS?
I didn't hear that last part with the door opening.
Oh, no, GIS. Like, do you use the mapping out of CAD, go with
Yes,
that
when I
type
say-
of alignment, and then,
It's a little bit of all of it. So a lot of LiDAR runs by the AV companies. So any route that they're going to do, they have to run through, LiDAR it, take all that, create the high definition map, then look at either engineering documents, as-built, or they sometimes send out their own surveyors if it's a really complex intersection to better understand and measure exactly what that is. So there is a huge amount of effort that it takes in order to get an AV route kind of planned out today with the current technology. When you're not like in a southwest city that has really wide streets and like, you know, it's flat and open. You know, that's the reason that they started over there. They're eventually going to work their way east and get into a lot more congested, tight, like compacted areas that are going to challenge the AIs, and that's what we should be doing. But yeah, they do a lot of it on their own right now. They need us for more of the status of what changed from the time they went out there and did it to the time they're out there running.
Well,
where do you think departments like yours or cities will get their revenues as parking comes down and all these other places where you're currently getting revenue? Where do they foresee that going?
That is a big question mark, man. But I would say that in the meantime, you know, we probably need to move more towards dynamic pricing of our curbside and the parking associated with it. So if that area is going to see overall a decrease in demand, then you know, I need to look at how I do more of a demand responsive type of pricing algorithm for that, because then I might be, you know, not doing so good on low demand, but at least in the city of Austin, we have, you know, really big events that happen kind of every weekend. And so I could change that maybe perhaps by looking at demand-based parking management to start off with, but that's only get me so many years. I got to come up with something else to get me the rest of the way.